All right, so we talked today in class about how we're going to start comparing decimals. And today in class, what we really looked at was not so much comparing decimals as it was putting a decimal on a number line. But the reason we talked about that is because starting tomorrow, we're going to compare decimals. So this homework that you're going to be doing tonight is a kind of a preview to see what you already know how to do. So I'm going to talk you through a little bit about what you need to do on tonight's homework, and hopefully it'll make it a little bit easier for you. And I'm actually going to be using your book on page 49 if you want to follow along with me, if you brought your book home. If not, no worries, just watch the video and you'll catch on pretty quick. So when we're looking at comparing decimals, we can do it multiple ways. One way we can do it is we can use a number line. So remember, when you're looking at a number line, what's on the left is always going to be smaller than what's on the right, as long as we're talking about those positive whole numbers or decimal numbers. So let's look at our example. Luis downloaded 2 songs onto his MP3 player. Which song is longer? So there's 2 songs we're talking about. Song number 1 is 3 6/10 long, and song number 2 is 3 8/10 long. So we have to compare these numbers. So one way we can compare is we can put them onto a number line. And we can see that 3 6/10 goes before 3 8/10. So any number that goes before, we know is going to be less than the number that goes after it. Numbers to the left are smaller than numbers to the right. So one way to compare numbers is to plot them on a number line. So we know that 3 8/10 is going to be greater than 3 6/10. Now, another way to do it, and this way is probably going to be the way that you are going to do it most of the time, is to line up the decimals. And this is still how Miss Ross has to do it sometimes. So you line them up, making sure that the digits in the same place value are right on top of each other. A great way to do that is to make sure those decimals line up. Okay? Then you're going to start to the left, and you're going to go until you get to a number that is different, to a digit that's different. So we start here in the ones place, and we see that the ones place both has 3s, right? There's 3s in both of those. We can't compare it because it's the same. So we move on to the next digit, place value. And in that place value, the 10th place value, we see a 6 and we see an 8. So all we have to do is we have to compare those digits in the 10th place value. And we can see that the 8 is bigger than the 6. So because the 8 digit is bigger than the 6 digit, we can say that 3 8/10 is bigger than 3 6/10. So that was song number 2. That's longer. Okay? Now, this is something we started to talk about today, and it's something that's really going to help you. Decimals that have the same value are equivalent decimals. This is a vocabulary word that you are going to need to know from now through high school. Equivalent means equal. It means the same. So let's look at what they've got for us. They've got the fraction 8/10, or the decimal 8/10. And all that means is out of our whole, we divided it into 10 pieces, and we have 8 of those. 8 are shaded in. So this is 8/10. Now let's look over here into this whole. This whole has been divided into 100 pieces. And 80 of those pieces have been shaded in. So that's 80 out of 100, or 80 hundredths. Now do you notice that these 2 shaded areas are the same size? 8/10 and 80 hundredths. It's the same thing. The shaded part of each model is the same. So 8/10 is equal to 80 hundredths. This is when we talk about when those zeros matter and when they don't matter. When we put a 0 at the end of a number, very end, it doesn't matter. It's the same number because it's an equivalent decimal. So for instance, if I had the decimal 4/10, that's equivalent to 40 hundredths. The 0 at the end doesn't change its value. It just changes its name. We could add another 0 if we really wanted to, and we could turn that 4/10 into 400 thousandths. Each of these decimals are equivalent. They have the same value. They just have a different name. They look a little different. Remember, I talked about me at home and me at school. I'm the same person. But at home, I dress differently. My name is Lauren. That's what my friends call me. At school, I dress in my very nice clothes, and people call me Miss Ross. I have a different name and I look different, but I'm the same person. These decimals have different names and they look different, but they're the same decimal. Okay? Now, the models show you can annex, this is a good vocab word to know, or place zeros to the right of a decimal without changing its value, which is what we talked about. We can change the way it looks, but not its value. Let's look at this example. We have 8 and 69 hundredths, and then we have 8 and 6 tenths. In my mind, I'm going to think, well, 69 is bigger than 6, but tenths are bigger than hundredths. So how do I know which decimal is bigger? I could put it on a number line, or I could use what I know about equivalent decimals. We can annex a 0 to the right of 8 and 6 tenths, so it has the same number of decimal places as 8 and 69 hundredths. I can put that 0 here because it doesn't change its value. It only changes its name and the way it looks. And now I see that I have 8 and 69 hundredths, and I have 8 and 60 hundredths. This is a lot easier for me to compare and know that I get it right. 8s are the same, 6s are the same, 9's different, so this is my bigger decimal. So 8 and 69 hundredths is greater than 8 and 6 tenths. Do you see that? All right, so let's just real quick look at this guided practice, and then I think you'll be ready to do your homework. All right, so I have 5 tenths and 7 tenths. I can use the number line to help me out. And plot over on my 5 and on my 7, and I can see that the 5 tenths comes before the 7 tenths, so I know that 5 tenths is less than 7 tenths. I can also use my other strategy, line them up on top of each other. Zeros are the same, 5 is less than 7, so 7 tenths is my bigger number. 7 tenths is bigger. Let's look at number 2. 4 and 40 hundredths, 4 and 44 hundredths. We can plot it on our decimal. There's 4 and 40 hundredths. There's 4 and 44 hundredths. I know that whatever's to the left is less than whatever's to the right. I can also line it up. 4 and 40 hundredths, 4 and 44 hundredths. And I can compare. 4 is the same, 4 is the same. 0 and 4 are different. 4 is the bigger number. So I know that 4 and 40 hundredths is less than 4 and 44 hundredths. So hopefully this will help you a little bit on your homework. Remember, if the decimals aren't the same number of place values, add that 0 on to help you out. Make an equivalent decimal. All right, good luck on your homework. We'll go over the answers in class tomorrow.